Okay, welcome. This is a quick demonstration video for measuring a stockpile's volume using LTI's 360 laser rangefinder and Softree's Terrain Tools product. Terrain Tools is also a module of Road Eng so that you can use full Road Eng as well to do this. Let's get started. So prior to this demonstration, we've already paired the laser rangefinder with the software in the computer. Instructions for that can be found on Softree's support knowledge base. To get started, let's open a new Traverse document. So the first thing we're going to do here, after we accept these defaults for just the initial coordinate position, we're going to retrieve what we call a screen layout. Screen layouts customize the look of the software and the column arrangements and stuff. So we're going to grab one here that we've preset up for the laser rangefinder. You can create your own screen layouts or you can customize the columns of the Traverse document yourself. So the first thing we're going to do is take a bunch of radial shots. So let's change this initial shot here over to radial from 4-shot. I'm going to put in a target instrument height here of 1.8. That's my eye height. And we're going to get ready to take our first shot. The device, as I mentioned, it's already paired. We're actually literally out in the field. We have a laptop as well as the laser gun working together, and let's take that first shot. Okay, we've got our first shot here. Just press the Enter key, and that'll save it into the survey map document. Okay, so we're going to use the label column here to give us a bit of what we call like a point code. We're going to just label this one as toe. So we're going to go ahead here and just continue shooting some of our radial shots at the toe of the pile, and then transition over to shooting the top of the pile. So we went ahead, continued to survey our pile. We did pause the video here for a second just to skip you having to watch us go around the entire pile. When we changed positions though, however, we did record that position change as a 4-shot, and you'll see that right here in the survey. One of the things that we could have done a little bit better during our survey would be actually to have written our labels in as we took each shot. We did know, however, though, where each type of labeled toe and top started, so we're just doing that after the fact, but for complete accuracy, we would highly recommend doing that in the field. Okay, let's save our survey and take it over to the terrain module. We're going to select File, Open, and go down here to our file type, change that over to a Traverse file so we can locate the one that we just saved. Select our file, hit OK. Let's turn on the labels. These are the comments that we recorded in our survey. There they are. It's a little bit better. Now, we don't need all of these lines. So let's select everything. We can do that by hitting Control A. And now let's deselect that actual traverse we recorded by hitting Shift-click on those lines. With just our radial shots selected, we're going to modify their feature property so that they're no longer connected. We can do that over here in the Feature Properties panel by adjusting or deselecting the Connected option and hit Apply. Now we will need to create a polygon feature that's going to represent our toe or the boundary of our pile. So we go up here to New Feature, so we can select Draw with the mouse, and in this case we want to make sure it's a 3D feature that is connected. Now we don't want to worry about the elevation because we're snapping, and I'll show you here in a second. This is going to allow it to pick up the elevations. So we can see the snapping feature selected here in this menu, but we are going to turn off the ability to snap to labels. So now we're just going to snap to the specific feature points. You can see the cursor change when the mouse is right in the right place to snap to that feature point. Now, I think we need another point in here. We missed a point. It looks like we missed a point when we surveyed, and that's probably just because we were lazy. It is a demo video, but for the purposes of this demonstration video, we're just going to add another one in. Now, when we add in a point, on a feature line like this, it does interpolate the elevation between the other 2 points. So our z is roughly going to be, appropriate. We're just guessing a little bit on the xy. Now we could continue to join the top points to make them a break line, but I don't think we necessarily need that. And let's make our surface first in order to check. One final thing before we do create that surface or that tin model, we need to set our toe to be a tin boundary. And again, we can do that over here in the feature properties panel on the side. Now up to our terrain modeling tab, press generate tin. We can skip the contours and now let's calculate our volume because our surface looks okay. If we had surveyed the original ground or had another previous survey to calculate against, we could calculate the volume between 2 surfaces. But in this case, we can calculate the volume just between our tin boundary or our toe, and we'll use that to represent the original ground and then the rest of the pile survey. There's our volume. It is showing that it's cut, and that's just because we need to switch the original and the final tags. In this case, our tin base boundary should be the original, and our surveyed pile should be the final. And there it is. We've got our stockpile volume. And that's it for this quick example. Please check out other examples of calculating stockpile volumes between 2 surfaces and other earthwork calculations over on our YouTube page. Thanks for watching.